Question number 6. The curve has an equation which satisfies the second derivative 6x minus 4. The point P at 2, 11 lies on the curve, and the gradient or the slope of the curve at P is 9. So a couple things here. We need to solve for y, and we've been given a coordinate on y from this point here. Okay, so that tells us that the y value when x is equal to 2 is equal to 11. We've been also given some information about the slope at P, and we know the slope at P is 9. Well, what that means is that at the derivative at x equals 2, the slope is equal to 9. So we have that ordered pair. So we need to use that to solve for some of the constants that we're going to generate when we solve for the y. So starting with d squared y over dx squared, I'm going to anti-differentiate to get dy by dx. And when I do that, I end up with 3x squared minus 4. But I have a plus c, sorry, 4x. And then I have a plus c, which I have to solve for. Now I can solve for that plus c because I have a value of y prime. And I know that this is equal to y prime. So I know y prime at 2 is equal to 9. So I'm just going to plug in 2 into my derivative. And when I do that, I only have a c left to solve for. So I end up with 9 is equal to 12 minus 8 plus c. This is equal to, so 12 minus 8 is 4, subtract 4 from both sides. I get c, and I'm going to call that c1. c1 is equal to 5. So my y prime equation then, which is dy by dx, is going to be 3x squared minus 4x plus 5. So then, using that equation, I'm going to integrate both sides of this, and I'm going to get y. So anti-differentiating, I get 3x cubed minus 2x squared plus 5x. But I also have a plus c, and I'm going to call this c2. And I need to solve for c2, and I can solve for c2 by using the ordered pair when y equals 2. Sorry, x equals 2, y equals 11, and I can plug in my 2 into my function. And I can solve for c2. And when I do that, I get 11 is equal to 8 minus 8, which cancels out, plus 10 plus c2. Those are zero pairs, so solving for c2, I get c2 equals 1. So then my equation is going to be y is equal to x cubed minus 2x squared plus 5x plus 1. And that's my equation for y given the second derivative. I'm just going to write that down here. Given the second derivative and the point and slope given for 6x minus 4. So there it is.